We will continue with the discussion on solution of differential equations using Laplace transform. Second question is solve y double dash minus y is equal to t with the initial conditions y of 0 equal to 1 and y dash of 0 equal to 1. So the solution of differential equations means the function y which satisfies the equations. So as in the previous problem, first take the Laplace transform on both sides, that is L of y double dash minus L of y is equal to L of t. Okay, then what is L of y double dash? L of y double dash is equal to s square into y of s minus s into y of 0 minus y dash of 0. Recall that y of s is the capital Y of s is the Laplace transform of small y. So this is L of y double dash minus what is L of y? L of y is our capital Y of s. Then what is L of t? Laplace transform of t. Laplace transform of t is 1 by s square. Okay, so take y of s outside, that is y of s into s square minus 1. Okay, s square minus 1 minus s into what is y of 0? Y of, given that y of 0 is 1 minus what is y dash of 0? Again y dash of 0 is 1, that is equal to 1 by s square. Then that is y of s into s square minus 1. Moving the two terms minus s and minus 1 to the right side, we get 1 by s square plus s plus 1. Therefore y of s is equal to 1 by s square into s square minus 1 plus s divided by s square minus 1 plus 1 divided by s square minus 1. Okay, then that is y of s is our L of y. L of y is equal to y of s is equal to this one. You have to find out function y which satisfies, which is the solution of a differential equation. Taking Laplace inverse Laplace transform on both sides, we get L inverse on both sides, we get y is equal to L inverse of y of s. L inverse of y of s is equal to L inverse of 1 by s square into s square minus 1 plus L inverse of s divided by s square minus 1 plus L inverse of 1 by s square minus. Okay, then first find out L inverse of 1 by s square into s square minus 1. Recall that this is of the form L inverse of f of s into g of s. Using convolution theorem, by taking f of s is equal to 1 by s square and g of s is equal to 1 by s square minus 1. That is L inverse of f of s into g of s is equal to convolution of f of t and g of t, that is f of t star g of t, where f of t is the inverse Laplace transform of capital F of s, that is 1 by s square, and g of s is the g of t is the small g of t is the inverse Laplace transform of 1 by s square minus 1. So we can, using convolution theorem, we can find out L inverse of 1 by s square into s square minus 1 is equal to sin ht minus t. So therefore y is equal to, first term is sin ht minus t plus what is L inverse of s divided by s square minus 1? It is of the form L inverse of s divided by s square minus w square, that is L inverse of s by s square minus w square is cos hwt. Here the value of w is 1, therefore it is cos ht. And similarly, what is 1 by L inverse of 1 by s square minus 1? L inverse of 1 by s square minus 1. It is of the form L inverse of w divided by s square minus w square, w equal to 1. This is sin hwt. Here the value of w is 1, therefore it is sin ht. This is the final answer.